Ever wondered what happens when a curious mind meets the complex optics of human eye? Well, our today's guest just not wonders, he builds labs, cracks equations, and mentors future optometrists. Joining us today for OptiSphere Me podcast is none other than Dr. Shrikant Bhardwaj. Dr. Shrikant Bhardwaj is a visionary optometrist, a research powerhouse, and a kind of teacher who can explain wavefront aberration without putting you to sleep. He started his journey at the Light School of Optometry in India, followed by a deep dive into vision science at University of Berkeley and postdoc at Indiana University. And then he came back to India to set up the visual optics lab at LV Prasad, Hyderabad. Today, he is not just studying how we see the world, he is helping us to see the world better. From keratoconus to computational methods, from research grants to Fulbright fellowships program, Dr. Bharadwaj wears many hats and probably adjusts them tilt for tilt and astigmatism. So let's get comfy. So get comfy, grab your coffee or your trial and set, and tune in for a chat that's part science, part story, and fully inspiring. You to the podcast. How you been doing?
I'm good. Thank you so much for that introduction, Neha. It is very embarrassing, and I've known you as a student long time ago. So chatting with you is lots of fun. I'm looking forward to the next several minutes in this. I'm not sure I'm going to be inspiring, but I'll tell you whatever I have done.
Um,
Thank
so
you.
let's start from the beginning. From Allied School of Optometry in India to Berkeley to Hyderabad. Was it
Yeah.
a
Was it a
curiosity,
what? Was it
or
a
was it just a coincidence, or curiosity, or a cosmic alignment?
It certainly wasn't a coincidence because this was certainly a planned activity. You can call it a cosmic alignment because I very firmly believe that the stars have to be aligned for things to materialize. At elite school, at undergraduate training, one thing that became very clear to me is just doing the routine clinical work is not going to satisfy me. You sort of needed to go deeper into understanding why a particular problem is manifesting itself and things like that. And cosmic alignment, as we are speaking, brought me in connect with a guy by name Professor Mike Webster from University of Nevada, Reno. Mike was on a sabbatical and he had come to elite school, and he started working on some very basic psychophysics experiments involving blur processing, color vision processing, and things like that. Uh, I sort of tagged along with him, and that was my first experience to vision science research. So whatever that I have achieved so far in the next 25 years, all thanks to Mike and his ability to mentor somebody as fresh as me who had no idea about vision science. Turns out Mike was a graduate of Berkeley, and he inspired me to apply to Berkeley and wrote a really nice recommendation letter, which is one of the main reasons that I could actually pursue grad school at Berkeley. And there I met even more inspiring, people. My PhD advisor, my co-advisor, super inspiring guys, optometrists, psychologists, mathematicians. I mean, all kinds of people who are sort of working on understanding the vision aspect. 5 years at Berkeley to completion, and then there was a postdoc at Indiana for another 4.5 years. That was switching gears to sort of studying how babies actually saw and how their focusing eye alignment and things like that works. But all along in this, in this journey of 10 years, one thing was very clear. You have gone to the US to study, you are gaining knowledge there, you are building your contacts, but the goal was always to come back to India. So as and when the thought process started that I should go back, and I contacted people at LVP, at Shankar Netralaya, my alma mater, and the return journey started. So 2009, things materialized, and I made a move back to India. So more of cosmic alignment in my mind rather than coincidence. It was not a serendipity at all.
Here I understand that though it was a cosmic alignment, there was a inside curious mind who wanted to explore more about vision science. Am I right?
Yeah,
So
of course, yeah.
this, along with the cosmic alignment, along with your journey from US and your thoughts of coming back to India, many of us want to go study abroad,
Yeah,
and wish to, many a time our parents, our mentors, and our family members, they are scared that they have a doubt that whether we are going to return back to India. What inspired you exactly, though you had this in mind that I want to come back? Idea was always to come back to India. Was it the family wanted you to come back, or your own wish? What inspired you way back then?
yeah,
Because you have
yeah,
a
yeah.
in US in optometry. What was the thought of coming back to India?
Yeah. So the thought process of coming back to India very seriously was actually a 3 year long journey. Because from the time that you sort of made up your mind that you want to go back to actually making the move, there were several sort of steps in between, right? I think the biggest one in all of that is to say that, okay, I want to very seriously try going back to India, and I'm returning to India not because I did not have options in the US. I'm going back because I truly want to sort of come back and make a difference to whatever I'm doing here. The main reason to actually come back was you realized that there is so much more in optometry than what is happening in India. And if you continue to stay back in the US, you would be one amongst the many scientists who are there. There is always it's a path that is very well laid out. So you will travel that path, and then you will be one amongst the many. So Dr. Rao here in LVP keeps talking about the road not taken or the road less traveled. So that is going to give you challenges, but what the hell? Let's give it a try, and if it works out, it will be good. And that's the path that I took to essentially come back and at least bring part of what's happening in the West to our country, and spawn more people like this, so that this culture of vision science research gets built here as well. Incidentally, that question that you asked me, was it parents, was it something else? That's been, that was in my mind as well for the longest of time. In fact, I used to go and search for blogs to say, why are people actually returning? And you're right, majority of the time it is actually parents who are ailing. There is some other kinds of personal commitments that are there, or jobs didn't work out in the US for people. I fortunately, my parents are healthy. There I had many opportunities for a job, so none of those clicked. So, but it was sort of the tug in the heart that you said you wanted to go back and do things. And the threshold point was I had done enough of number of years as a postdoc. You had to apply for a faculty position in the US, and if you get into a faculty position, it's another 5 years of your time. So then the transition is not going to happen. The more you are entrenched in the environment there, the less likely that you are going to return. So that was the point when you said, okay, if the chance for a return is happening now, you are going to do it. And yeah, fortunately, it worked out.
Gladly, you came back and taught
Yeah,
us. And
thank you.
so we had an opportunity to visit your lab, the visual optics lab. So can you walk us through the early days of visual optics lab? How did you set up, and
Yeah,
what were the challenges and key learnings there in the
yeah,
initial days?
yeah. So the transition, was certainly facilitated by several people here at LVP, including Dr. Rao, Dr. GC Chandrasekhar, Dr. Prashant Garg. Uh, I was very conscious of the fact that I am coming from a very core research environment, bioengineering sort of an environment to a clinical environment. And I've got to sort of change my thought process or the way I approach the science questions here at LVP than back there. I still remember the first time I gave a talk here at LVP, and I was talking about all my PhD related work. You could see the glaze in people's eyes. They didn't necessarily relate to what I was talking. Secondly, that level of physiology and stuff were not attractive to people here. They're obviously very smart individuals, but it just didn't gel in with their thought process. So that was my biggest learning, is while I want to sort of pursue that line of research, to fulfill my own curiosity, if you have to survive in an environment like this, you also got to give what's needed for people. So that really what sort of diverged my research into two branches. I still continue to do all that accommodation versions, modeling, and things like that. But at the same time, I do clinically translatable research that connects better with the clinical audience that I appeal to here.
So, what I understand here is that conceptual models, computational models,
Models, yeah.
then behavioral models, behavioral optometry, and then experimental optometry. You have studied in these three areas. Which is the as per the current research scenario in Indian, like in our institutions, which is the model which mostly fascinates you, and where should a young generation optometrists or scientists should focus more?
Yeah, yeah, yeah. So if I can take a step back on that question, Neha, uh, it goes back to the purpose for which I sort of returned back to India, right? In a purpose in my own mind. The the goal was never to recreate what is happening at Berkeley or Stanford or Harvard's and things like that, right? Their modus operandi is very different from what you can actually contribute here. The idea is to develop something that is complementary to what is happening there. So together you can actually, come up with a bigger picture idea. The strength in terms of the theoretical sciences that they have, the resources that they have to actually build those theoretical sciences is never going to match in an Indian scenario at this point. Our strength is the ability to translate some of those theoretical concepts into practical reality for patients, either in terms of understanding the pathobiology of the disease or in terms of coming up with newer treatment protocols, understanding the basis for those treatment protocols and things like that. So that thought process has sort of been the primary thread in my research, and that's what I would advocate for the younger generation of people as well, which is uh, what you
Experiment.
are yeah what you're going to contribute here is the translational element. People in Berkeley or Stanford, they don't see these kinds of cases that we see here, right? They have the tools to understand these cases. It's somebody has to bridge the gap between the clinical sciences and the basic sciences, right? So my lab sort of functions in that cusp. I am a clinician to the hardcore scientist, and I am a scientist to the hardcore clinicians. So you sort of, in that you can feel very bad about it because you have a split personality in the sense, but that is also the space in which you operate and you thrive that many people do not have the luxury to do.
Okay, so how do you my question here will be that how do you exactly bridge this amalgamation, what we
Yeah,
say, from the to the laboratory? Because most
yeah,
of the time what happens with me, if I'm into experimental mode completely, I'm stuck there, and then coming back to the clinics and having those kind, having our clinical days, as Dr. Prem Nandini was mentioning as well, we should divide it, uh, divided in a way that we are fully focused on the clinics part, and then when we are into research, we are completely focused there. In your case, how do you actually manage these kind of
Yeah, yeah. Honestly, it's not easy to manage, Neha. Putting on a scientist's hat and switching it over to a clinician's hat is not a straightforward thing. And the reason is reason is very simple in my mind. As a clinician, you are expected to deliver answers to your patients almost immediately, right? You can't sit around deliberating on a problem for ever and ever because the patient needs to be addressed. In research, if you claim that you have an answer for something immediately, you are almost looked down upon because you haven't clearly thought through the situation. So, deliberation, thinking about things for several weeks, months is the name of the game in research. These two don't necessarily sort of immediately connect with each other, right? Um, for me, I belong more on the scientist space of things than in the clinician space. I'll be very honest here, right? I would rather spend time thinking about the problem and trying to come up with theories for why such thing is happening rather than actually managing the patient. So the way I bridge that gap is to actually partner with a lot of clinicians. Nandini, that you mentioned, she is a partner in crime for several projects that we are doing. So she has the clinical insights, she has the clinical acumen. I bring in some of the theoretical ideas into it, and together you sort of are able to address a clinically relevant problem using the basic science tools. One example of this that I think we have taught the world is about understanding the pathobiology of this condition called a spasm of near reflex, also called accommodative spasm, pseudomyopia, and things like that. Turns out from Nandini's clinic, because of her diligent record keeping, we now have the largest number of cases of this condition across the globe. And the profiles that we are seeing is very different from what has been reported in the literature from the West. That's one. Secondly, the partnership between a clinician and a scientist, and I'm putting the clinician's hat on Nandini, and I'm putting the scientist's hat in myself. We have been able to understand the physiology of this condition quite well. We have used controls engineering, modeling, a lot of experimental techniques to actually try and understand this problem. So, if we have a what I think is a comprehensive understanding of the disease condition, or at least tending in that direction, it's primarily because you had access to these patients, you had access to the tools that you had learned, and you also had the right kind of people that were ready to sort of connect these two things up. So even while I personally am not in the clinic, I do have strong clinical partners who provide that kind of insights.
Okay. So I think this solves a lot of queries out there that was experimenting, theoretical understanding, and writing papers. Coming to writing papers and putting your thoughts across, it requires a lot of your bandwidth and time. So it is
Yes,
important to have a team of people together to run a project rather than doing it all alone.
correct.
So what is more fascinating or stressful? I would ask, is it setting up an experiment or writing a paper?
Um, when I was so again, so just to backtrack a little bit on this, Neha, one thing as principal investigators of labs, I think we have to realize that we are actually running a mini industry, right? A mini industry where you are responsible for the science that you are doing or the products that will come out of an industry, what space that you are operating in. You are responsible for the human resource, the consumables in the lab, the tools that you use in the lab, funding for all of this. So as a PI, you are sort of continuously on the job of okay, looking for funding, churning out research papers, adding more research to your plate and things like that. So it's a continuous process. And clearly, like you said, it's not a single man done activity. We have a slew of research personnel, project optometrists, and stuff who can actually do this. And my job over time has become more of a person who conceptualizes the experiments, works with the students to set up the experiment, and eventually write the paper. Right. So to me, uh, honestly speaking, 15, 20 years ago, when I was early to this game, writing papers was more stressful than actually setting up the experiment. But now I think both have sort of become equally, what do you say, possible to do. I enjoy actually setting up the experiment. I miss being in the lab. But it's for the students to actually go ahead and do that more diligently. Writing papers, I find it enjoyable because you are able to convey your thoughts in a clear manner, and ultimately that's what people are going to read. All the effort that goes on in the lab, all the failures and stuff that has happened, never sees the light of the day. So how well you convey your information through writing is what it is. So I enjoy doing both actually.
Yeah. So let me take you to the PhD days. Along.
Yeah.
Yeah. So what I thought initially when I was studying, I was doing my PhD. I have, data work is very important. Data collection is very important. Writing will happen.
Right.
Eventually, I realized it is not so. So can you put some light on data collection plus, writing your papers, writing your theses? How was your journey, and what did you learn? Or what are the key?
Right. So fortunately, I had a PhD mentor. Incidentally, I still work with him after 25 years of starting my PhD. Uh, he was very aggressive in terms of writing papers. So he sort of put that bug in you that you've got to timely write the papers, send it out, and that's the only way that you're going to sort of survive in academia. And the golden rule in the lab was if the data collection is completed within the next 3 months or so, the first draft of the paper should be ready. The longer you prolong that process, the less interesting that science work is going to become, and the more blurrier it gets. All the dirty little details that were there, you are going to start forgetting. And then the charm of writing that paper sort of goes away. So that's the rule that we still follow in the lab. As and when data collection gets completed or it's very nearly complete, the students are asked to actually start putting things down on paper. And you don't have to have a very clean draft and things like that. Put a brain dump, put everything that you know on a piece of paper, and then let's start refining it. Waiting for the stars to align before you want to start putting something on paper is never going to happen. You've got to almost start doing it, in parallel to your data collection process. What we do in the lab is, and this is again something that both my PhD advisor and postdoc advisor taught me, is spend a lot of time in putting the research protocol together. So until the time the exact question, the exact hypothesis that you're addressing is not clear, don't start data collection. So things in my lab usually by the time data collection starts, 70% of the project is already over because you have already done all that background work. You're very clear about what you want to do, what's the parameter that you're going to look at. Then data collection becomes more straightforward to do. So it's frustrating for students because they are constantly sitting and reading, writing things and things like that. But they eventually realize the importance of it because when the data comes, it's super easy to now interpret.
Yeah.
So that's my biggest advice to people.
So for the audience and for me also, what I learned here was that give 3 months of the time for data collection and start writing your papers simultaneously and put a good protocol.
Absolutely, absolutely. Can't emphasize that enough.
Yeah.
Because otherwise it's a fishing expedition, right? I mean, yeah, कुछ तो collect कर लेंगे फिर देखा जाएगा, and it never works that way in
Usually,
science.
I think for us as a student in the Indian studying Indian optometry in colleges, uh, many of us do not get it right. We always think first is the data collection. 90% of the work is the data collection. We wait for the data
Yeah,
and then put a words, put in writing, and scientific writing is something way, way different than what you're writing, what otherwise your knowledge is. Your Yeah. So can you put some a little light on scientific paper writing? How do we how should we go about it?
Right. So that's actually a loaded question, Neha. But very briefly, you are absolutely right that scientific writing is very different from from, let's say, popular science writing, right? The biggest difference is when you are actually doing a scientific writing, there is no room for emotions. There is no room for adjectives to be used, right?
Yeah.
Those all essentially convey your own biases. When somebody says, "Oh, this result is highly significant," highly is your bias towards the data, right? I mean, statistics has told you it is significant, and you are expected to write it that way. So it is a very cut and dry process. It You simply are stating the facts and weaving a story together based on previous facts that are there, identifying a very clear gap in the literature, a hypothesis surrounding it. So the entire process is all about thinking through a problem. The I'm going to go back to the previous question, because the thinking through process, if it has not happened at the beginning of your experiment, right, then scientific writing becomes a super tragedy, because you don't know what to write. The same data that you have collected could be thought about it from 10 different perspectives. So अब कौन सा perspective अभी आप लेने वाले हो? Only when those are clear at the beginning, then scientific writing is relatively more easier, because you are now saying, okay, this is the gap that I wanted to address. This is the data that is coming up. Either it is accepting the hypothesis, or it's rejecting the hypothesis. So that way, I would say the biggest thing to avoid in scientific writing is to avoid your emotions. In there is to detach yourself from your data. It's hard to do because you have done all that hard work and you want to sort of defend it to no end. But at the same time, data is actually talking to you. It is telling you, certain truths, and you have to accept that truth. I still remember one of my recent PhD students. She had a hypothesis that one-eyed individuals will do better than individuals who are temporarily closed one, because they are used to seeing this world with one eye, whereas normal binocular people are not used to doing tasks like that. Turns out the data didn't show us that. No matter how hard she tried, no matter what direction that she looked at, the data is not showing us that. So her favorite hypothesis, or my favorite hypothesis, is not fulfilled, and that's what the data is telling you, and that's what you need to accept, and start thinking about why is that effect not showing up. So it's a hard problem, but uh, that's something that needs to happen if you want to do quality science.
I think in research, it is important that you think that you are creating an elephant, but at the end you get another sort of animal altogether. Like you create something which is way different than what you initially thought of.
Totally, totally. And if you claim in your paper that you have solved the whole world's problems, then you're clearly making a fool of yourself, right? So Einstein's theory of relativity didn't solve the world's problem. Clearly, our science will not do it. So we've got to accept, if that research study opens up another elephant, like you're saying, that's the best thing to happen, because that has provided you some insights that you're using to try and answer some other problem. Yeah.
Yeah. So I think thank you for answering so honestly on the research part, and we got a lot of insights on that. Scientific writing particularly was very difficult for me as well. And this one, like taking your emotions out of writing, it was truly a takeaway. Now
Mhm.
let me take you through your teaching journey. Okay, so
Okay.
training and teaching is something which is close to OptiConsult as well. So how it is for teaching future optometrists like in India right now, more like running a marathon or planting seeds. How is it?
Both, I would say. Uh, I want to recall a very fond incident that I had when I returned to India 2009, and I started teaching my first course on binocular vision. I was a teaching assistant at Berkeley for my PhD advisor, and that's really where I sort of learned all that he taught. And I took those notes. I made my own flavor out of it, and that's what I started teaching. The mid semester reviews come back, and students are all complaining, saying that, oh, this is PhD level material you're teaching. The previous person had not taught this. I don't think this is expected out of optometry students, so on and so forth. Um, and the only counter argument I had to give them was twofold. One is, you guys are an undergrad, you don't even know what PhD level material is, so you have no rights to be commenting on it. Secondly, if optometry students at Berkeley are learning this, you guys are also fully capable of learning this. They are no different from you guys in terms of intellectual capability. So if you are being taught something that is lower in standards, that's actually is an insult for you, and then you shouldn't be accepting it. And once I had this very candid conversation with the students, they came along, and two of the students from that cohort actually joined my lab for good 5-6 years. They were there in the lab. You may know them, Praveen and Vinay, in the lab, and remarkable guys. They did remarkably well. They are now PhD holders, doing postdocs and things like that. So clearly what that taught me is that it is both that marathon that you said and also planting the seeds, right, Neha? Because it was easy enough for me to dumb it down, but I'm not doing them any favor at all, and I'm also going to get bored in that process. So one thing that I keep saying to myself and also to the students in the lab is, I am not going to, not in the lab, the students in the classroom is, I am not going to reduce this level, right? I am happy to explain this concept to you in many different ways to the extent possible. But what you need to know about this, you need to know about it. So if anybody else in the world knows about it as an optometrist, you should also know about it. So that's been the mantra, and several people suffer initially. I realize that also, but by the time they sort of get to, let's say, one third of the semester or half of the semester, they are up and running. They get and the class becomes a lot more enjoyable for them and for me. So I don't. I think it is teaching semester long courses or year long courses is a marathon, because you sort of work with the same person over a period, but you also form a very nice bond with the students, that you understand them, you understand their way of thinking, and you have the capability to plant those seeds that they will eventually sort of take it and move forward.
So, the key takeaway from teaching, from your teaching experience is that it's always to teach right to the student, and have a and complete, rather than teach partial and make students happier, but teaching right in a right, very important.
Exactly. I mean, it's like parenting. You can spoil your child giving all the goodies. End of the day, you then don't complain that I have a not a not so great individual that I have parented. You only created that problem, right? So you can be hard on them, you can be firm on them. You don't need to be annoying to them, but at the same time, you are teaching them tools and skills that they will use for the rest of their life, right? So the ownership is on you to actually give them the best.
Yeah, and the communication is a two-way communication where you also hear from your student,
Oh
and
yeah, yeah, absolutely. Fantastic point, actually, Neham. I'm glad you brought this up. My understanding of Duane's retraction syndrome, for those of you interested in strabismus, was actually taught by my student. The way Bhagya taught me what Duane's retraction syndrome is, I don't think I even understood it that well. In her own mind, she had worked it out and she verbalized it, and I used that explanation to actually teach my students. So it's absolutely a two-way process. No doubt about that.
Yes, we learn so much from our juniors and students. So learning is a lifelong journey. So, so after this, coming towards the end of our podcast, we have an interesting section here, which is a surprising element which I have not shared with you. So
Okay.
it is a rapid fire round, which is going to be very interesting. I'm going to ask you some questions in a rapid fire format, and you have to answer me. So,
Okay.
so I'm going to shoot the questions now.
Okay.
So one subject you struggled with in your college days.
Binocular vision.
Oh, really?
Yeah. I in fact almost met with an accident thinking about the damn stuff.
How did you cope up with that?
I had to think it through. And once my PhD advisor played a huge role in helping me gain that, give me those insights. And lo and behold, I mean, for the rest of my life, I think I'll be doing that only.
Yeah. So I think making your weakness your strength at the
I
end.
think so. I
Yeah.
think so. Yeah.
So next question. Teaching or research? It's going to be interesting. What's more fun?
Research.
Research.
Sorry to even though I've been teaching all along, but given it, I mean, obviously I would want both, but if you have to do a forced choice behavior, I will pick research.
Research. Okay. One second. Okay. The next questions. This is going to be a little confusing also maybe. So book. So for you, books, podcast, or movies. Your way
Hmm.
to relax. So podcast is something new to you.
Yeah, yeah, absolutely right. For me, movies, it is Neha. Like I said, I belong to the dinosaur age, so this podcast thing is new to me. Although your podcast will probably inspire me to go and look at more. I do like movies. I do watch them occasionally. So if I have to chill out, I will certainly do that. I did that last weekend. The books I do read, but I'm not a voracious reader. So if I manage to finish 3-4 pages in an evening, I consider that a success.
Interesting. A researcher, a scientist, a movie buff, also.
Yeah, I'm not a movie buff, so I wouldn't know many of the new things happening. But I do like older movies, movies that World War II movies. That I am a buff of. I agree. Yeah.
Who says scientists are researchers are boring? They also like to do things which all of us do. So yeah, your favorite snack during your long lab hours.
Favorite snack. Uh, this banana chips that is
Yeah.
there, the Kerala banana chips. I mean, I am a quarter Keralite, so I do have a attraction towards that. So yeah, you put a packet in front of me, I will eat it until my arteries are clogged.
I think next time I'm getting you that. Okay. So, what is the one piece of advice you would give it to your younger self if you had to go back in time?
Don't take yourself very seriously, is the advice that I would give. Because over time, I have realized that I have stressed out on several problems, or what I thought was major problems, and lost peace over it. And I think in reflecting on it, I think the major reason for that is I was taking myself too seriously. I didn't have to do that. Things would have happened the way it is anyways. So my biggest piece of advice would be that continue to do your work, but don't take yourself so seriously that you lose fun in doing things.
Time will pass and things will happen the way it is. Right?
Absolutely. Yeah. If it has to happen to you, it will happen to you. Stars getting aligned. I have a very, very firm believer in that.
Cosmic alignment. Okay.
Yeah, yeah.
Thing people don't know about you.
Things that people do not know about
Yeah.
me.
Yes. Something about you we don't know.
I get angry very quickly. uh, and yeah, people don't know that very much about me because I tend to not show it, but the smallest of things can tick me off. And it doesn't matter whether it is lab front or work or home front or things. My friends know this of me. And in fact, they are the ones who pointed it out to me. And now, with my son, I am realizing he has inherited those genes, which is not great, but he has.
So yeah, but people who get angry fast get cool down also faster. So is it like that only? You take time.
For the most part, although sometimes I do tend to hold on to things unnecessarily, and this is where the taking myself too seriously bit comes in. I don't have to do it. I certainly have scope to learn where I can let go of things faster.
Nice. So one tool or equipment you cannot live without in your lab.
Oh, in the lab is a statistical package called MATLAB. It's a programming package that we use pretty much to run all our experiments, do all our data collection. So without that, I will feel super handicapped.
Yeah. So it's MATLAB.
MATLAB, yeah.
So one optical or ophthalmic term you enjoy using just because it sounds cool.
Blur.
Okay.
I in fact keep joking to the lab that we might as well change the name of our lab from visual optics to the blur lab because and there's a colleague backslash friend of mine at the Indian Institute of Science. He keeps jokingly telling me that you have this Olympian's ability to think about blur as a problem. So blur is my favorite word.
Okay. So one piece of advice you would like to give to the young scientist out there.
The piece of advice is that don't don't well, okay, two pieces of advice. One, science is a long haul flight, right? So don't look for immediate returns, and it is not going to happen, and you are not going to mature any faster with the short term benefits. So if you are getting into science, think that it is a long haul flight. You have to go through that journey. It's a frustrating journey. Whatever as scientists we get to present to you is the distilled version of what actually happens in the lab. So be prepared for uh, negative results. Be prepared for failures, but there is light at the end of the tunnel, and that's a very pleasurable feeling. The second piece of advice is you are doing science because you enjoy doing it, right? So you are doing it because you are personally interested in solving the problem. You're not doing it because 10 other people asked you to go ahead and do it. Then you're not going to enjoy that process. Yeah, so that's my advice. Long haul flight and do it for yourself.
That's a great piece of advice for our young scientists out there. So, yes, it is a long journey to take. Uh, for our young optometrist, what is one thing you want to give a message to all of us, for all eye care professionals, first?
Yeah, yeah. I think the message there, Neha, is this is specifically for the trainees who are there. I've been feeling that over a period of time, people do not think of the profession of optometry very seriously. They are looking for sort of immediate returns. At the time that I was in undergrad, and the decision of what I wanted to do next was very clear in my mind and in many of my friends' mind by the time the middle of internship actually happens, right? You've been thinking about it, and by the time October, November of that year comes, you're already clear this is what you want to do. I was talking to a student yesterday, as recent as yesterday, She is going to graduate next month, and I ask her what does she want to do with her career. She said, "नहीं नहीं, पहले घर जाऊंगी, then I will settle down, and then I will think about it." That's recipe for disaster, right? I mean, you have no idea what you want to do with your career, and default option is I want to go and jump onto another training program, not knowing what to do. So my advice is, you can have all the fun in your undergraduate days. That's the time to have fun, no denying it. But at the same time, don't postpone important decisions of how do you want to plan your career, what do you want to do with your career. Give that some thought as well. Not having that is like going to a railway station and then picking up some train and then going somewhere and expecting that good things will happen to you. It doesn't. It doesn't happen.
As you said, it's a digital world and people follow more digital content than having real mentorship. So yes, have your mentors out there, listen to them, and take wise decision for all our optometrists. So thank you, Dr. Bharadwaj, for having a wonderful chat session with us. It was truly, truly, truly inspiring to all of us. And this is not the end. We want to hear more from you, more about the experiments, more about your journey, more in the future. So thank you for joining us today for the podcast, and see you again.
Thank you, Neha. It's been a real pleasure, and I always enjoy interacting with you. So
Same
I
here.
look forward to the next such event. Thank you.
Yeah, thank you so much. And for the audiences, please tune in to OptiSphere podcast, like and subscribe to our channel, and wait for upcoming sessions. Thank you so much. Bye, guys.
All right.
Bye bye, sir. Bye bye.
Bye. Take care, Neha. Yeah. Bye.